Okay, good morning to everybody. Thank you to be here to listen to my presentation, also talking about gas turbine, let's say, according to this exhibition and what we heard so far, an old technology that can help to continue our future, to look the path for the decarbonization. So it's a lot of us today, and also in the previous presentations, talk about the revolution of the utilities landscape, and it's clear that how the energy now is produced and is distributing is changing, and this is changing really very, very fast. And this is creating a crisis into the infrastructural resiliency day by day, and this is a fact that we continue to see every day in the world, in different countries. Also here in France, a couple of days ago, there was an earthquake, and it was necessary to stop a couple of nuke plants in the south of France, creating a, let's say, disconnection and variable loads in some area of the grid of France as well. And this continues to happen in many, many countries, not only earthquake, but also everything that is related to the climate change. Our customer greenhouse gas reduction targets appear to come earlier than the limits that are fixed by the states and from the local regulations. So many of industrial customers, food manufacturers and whatever, they are putting their limits above in terms of limit and in terms of timing compared to what is regulated by legislation. And typically the main directions where we are all focused are the 100% renewable power, but how other speakers already anticipated, there is a main focus on electrical power, but it's only 1/3 of industrial needs, because there is also other needs in terms of steam, hot oil, thermal oil, hot water that has necessity to be addressed in order to be decarbonized. There is a focus on hydrogen and also the carbon neutral fuel, but also, and this is very important, especially for industrial application, make more with less. Means be efficient. Things to do the goods, the things that we are using in a different way. And this is an industrial example. Carlsberg beer is starting to introduce paper bottles rather than glass bottles. Maybe it's not so sexy bottles, but there is important meanings in this action. First of all, if you think about paper, or better something like a multi-layer paper, so you have paper, plastic, and aluminum. This is a typical package that is used already in milk and in other applications, but the energy footprint of this kind of package is sensibly lower compared to produce glass. That to produce glass you need more than 1,000 degrees C. But the point of Carlsberg is not that kind of footprint, but is the logistic footprint. Because when you have to transport billions of bottles of beer everywhere in the world, every year, there is a big weight that is related not to the product, but to the package itself. And this is a huge consumption of energy, and they want to be focused in this value chain of the CO2 in order to reduce also this kind of impact and having the possibility to reuse, let's say, this kind of package to do other things. Also, and this will be my case later, the toilet paper case is very important because tissue manufacturers understood that the tissue manufacturing has a huge impact in terms of energy consumption, but there is also the possibility working together with gas turbine manufacturer, with the technological provider of the producer of the tissue machine to reduce a lot the footprint, CO2 footprint for consumable like toilet paper. Another point is the resiliency of the grid infrastructure. This is an example of a couple of weeks ago where Pittsburgh Airport in the US decided to be the first airport in the world able to operate with a closed microgrid system. So they push to have a lot of renewable power, but they understand that to be reliable and to have power when they need, especially due to storms, cyclones, and climate change, they need also to focus on gas. And they decided to operate with CHP plant based on gas turbine in order to produce the right amount of electrical power and the right amount of thermal to heat and cool the complete volume of the airport. Of course, this revolution has a huge impact on my company. I work for Solar Turbine. Solar Turbine is the biggest industrial gas turbine manufacturer from 1.2 up to 25 mega. So we are not talking about big CHP plants, we are talking about industrial cogeneration. We are focused on industries, we are focused on local utilities. And we have a lot of customers. One of our main market is oil and gas market. It's the dirty side of the power, okay? But also in oil and gas, we have done a lot of job in order to reduce the fugitive emission in our gas compressor. You can imagine that, for example, when you have a gas compressor in a pipeline, in the past, the loss of the gas between the seals of the gas compressor was the 6% of all the gas that is vehiculated in the pipe. And natural gas means methane, has a huge impact as a greenhouse gas emission compared to the CO2. So what we did was to realize a system that avoid completely the fugitive emission and help also oil and gas market, again, the dirty market, to be more clean and to support this reduction of CO2. What we are doing, as anticipated, we launched a massive investment plan driven on sustainability with two directions, reducing the greenhouse gas emission and increasing the infrastructure resiliency. So currently, we have turbines that are able to burn many different typology of fuel, natural gas, all the typology of hydrocarbons, but also hydrogen in mixture up to 85%, and 100% of biogas, synthetic gas, landfill gas, and stuff like that. We develop a burning system that are able to reduce the NOx emission down to 9 ppm, and we have one unit that is able to reduce NOx down to 5 ppm. We develop a new solution in terms of burners for new generation of turbine, able to reduce the specific CO2 emission per megawatt produced. But more and more important, we are talking about digitalization. Our new products are completely enhanced for a revolution of Industry 4.0. So they're able to talk with the industrial process, with the grid, and to make power when it's needed and when it's convenient from the economical point of view. And that's the big revolution from our point of view of our typology of product. And also, I already anticipated the energy efficiency. When I'm talking about new fuels, hydrogen, for us is not a future, is now. I would say is our last 5-10 years. So we have already more than 150 units that are currently operating with high hydrogen, with high CO for coke oven gas application, but also with landfill, with biogas, and with digesters typology of gas. So we already have currently close to 1.6 million cumulated experience hours in our gas turbine in order to be able to provide power and heat with all the variety of different typology of fuel and mix of fuels. Let's make a case, because we all talk about hydrogen. So if we think about a 5.6 mega turbine, in this chart you have in blue the CO2 reduction emission, the CO2 emission, and the numbers that you have to look at are the right numbers on the chart. In orange, if it is orange, you have the percentage of reduction acting with different typology of fuel. So on the left side, you have 100% natural gas. On the left side, 100% natural gas. On the right one, you have biogas. What happened? If you think to have a target reduction of CO2 of 15%, the yellow line, the only way in mixing hydrogen into the pipeline is to have at least 50%, 50, of hydrogen made by renewable, so not blue or hydrogen or whatever, the green hydrogen made by renewable that has to be mixed into the pipeline. And this is a big issue because there is a technical, let's say, problem related to the material of the pipeline. And so what we are aware is that many countries are experimenting the mixing of the hydrogen, but the technical limits seems to be 12, 15%, absolutely far away from the 50 that is necessary to reach this kind of reduction. The other point, so for our perspective, the distributed hydrogen mixed in the pipeline is good, could be good locally if in some infrastructure, industrial infrastructure, for example in the Netherlands, we start to create a dedicated pipeline for hydrogen, but the better option for hydrogen is to use hydrogen centralized, where it's produced, and where maybe hydrogen is not 100%, but it's dirty. Why? Because if you have 100% hydrogen pure, maybe it's better to use for other things, for automotive, for fuel cell that has electrical efficiency of 60% rather than a gas turbine that has only 33. So we can use when it's pure in a different way, rather than when it's not pure and it costs like hell to purify up to 100%, we already have the solution to burn this into the turbine in a clean and efficient way. So also we have to understand which is the impact of the different, let's say, typology of fuel in the landscape of production on the left side of 1 mega of electrical power, and on the right side in the light blue 1 ton of steam, because we are talking about cogeneration. Of course, if we work with coal on the left of each chart, your emission is very high. If we are working with renewable or biogas or whatever, your emission per megawatt or per ton is absolutely less. But what happens when you combine the needs typically of 1 mega of electrical power and 2 mega of thermal power? If you look at the energy mix of the different countries, so from Poland, that is very focused on coal, up to Spain, France, and Belgium, that has an energy mix that is full of renewable and nuclear, okay, you see that the impact of 2 megawatt of steam and 1 megawatt of electrical power can be completely different. And sometimes can be absolutely comparable to the CO2 footprint that you would have to run an industrial CHP, so boiler, gas boiler, plus renewable, driven by wind, photovoltaic, or hydropower. But the yellow line that you see here, the yellow column, is related to a cogen plant. So a cogeneration plant, industrial cogeneration driven by a gas turbine, is able to provide you an emission of CO2 that for many countries, many states, not only in Europe, but also in US, and you can imagine also in Asia, can be a current, existing, suitable and reliable solution to reduce a lot the current footprint for industrial operation. So if we want really to be effective, we, in our opinion, should have to focus in those countries that has a good spark spread in vertical in terms to sustain the economicity of the economics of a CHP, but also act in tier 1 in the countries where the energy mix has high carbon footprint. And in this scenario, the cogen will be not the main driver, but will be integrated into the renewable grids, making renewable grids able to be more resilient and also sustainable from the economical point of view. And now, let's come to our case study. Make more with less. You know what is it? Exactly, easy. It's a toilet paper. Toilet paper, 1 roll of toilet paper typically is 100 grams of material. To produce this 100 grams of material, the consumption of energy is 90 watts of electrical power and 200 watts of thermal power. So think about that every time that you finish 1 roll of toilet paper, you allow the emission of this CO2 plus other fugitive hydrocarbon emission during the specific operation. The impact of CO2 footprint in US and Europe is 80 gram per CO2, 80 gram per roll of CO2. In Asia is higher due to the coal impact. And this is the amount of rolls, billions of rolls that every year are used everywhere. So my question to you is, do we think it's possible to make a step back and not to use any more toilet paper? No, I don't think it should be difficult. So what we did, the point of our application in gas turbine is to think different compared to the usual CHP. So with a CHP, you have a flange, and then you have the operation of our customer. What we do is to integrate our production into the production machine of the customer, making direct drying and using better the heat in order to reduce the CO2 emission. And I show you now some numbers in terms of economics, the black number on the top of the row, and CO2 emission, the red numbers. So without CHP, the operating cost in Poland of a Titan 130, it's a 15 megawatt machine for paper manufacturing, is close to 13 million only to produce the utilities. And they have an emission of 99,000 tons of CO2 per year. If they install a CHP, a normal CHP, so with a flange to produce the utilities, there is a huge reduction, mainly 49% less in cost to produce the utilities, with a reduction of CO2 of 21%. But when we are able to implement a digitalized cogeneration system, so connected to the production, connected to the grid, and able to use direct drying into the system of the customer, the reduction is bigger in terms of operating cost, but also in terms of CO2 reduction. What happened with the renewable energy? Of course, the CO2 go down, minus 67%, but the operating costs typically are comparable, many times are higher than the operating cost that you have with the non-renewable source. But do look at this. When the CO2 cost per ton will be $35 per ton, the tax saving using the green renewable solution in a paper manufacturer will be 1.5 million euro per year. Reducing, using a smart CHP application, the reduction will be 5 times more than that. So also, when we talk about green, many times, especially in industrial application, we have to understand what is sustainable also from the economical point of view, and to help and to support, our mission is to help to support our customer to develop integrated solutions also that are sustainable from the economical point of view. So my last slide. The renewable and distributed power generation is growing. So what is good here? There is a greenhouse gas emission reduction for sure. On a long term, the power cost expectation will go down due to marginal cost production, because you don't have fuel in renewable typically, and so when you pay back the infrastructure, typically the cost should go down. But minus, you have instability and resiliency currently in the energy infrastructure. Industrial CHP, what does offer? The plus, CO2 reduction compared to no CHP solution. Thermal production for industrial operation, we talked about thermal just before, so for industrial thermal is very important, it is the key factor for success. And can help a lot, many countries, the transition from the carbon to the carbon neutral economy. The benefit of a CHP based on gas turbine, reduction of greenhouse gas emission, and the possibility to use hydrogen, mixture of hydrogen and other typology of carbon neutral fuel, the enhancement of the grid resilience and stability, and the economical sustainability. So, thank you, and now just imagine what we can do together, working together for a better future and lowering greenhouse gas emission, also using old CHP concept. Thank you.